Okay, so today we're going to look at the next method of solving systems of equations. If we recap, so far we've talked about solving systems of equations by graphing, and then on Thursday we learned how to solve systems by the substitution method. And today we're going to look at the elimination method. The elimination method works all the time once again, and it's just another one of the methods that we're going to learn, hopefully get pretty comfortable with, because it allows us to solve a more diverse set of problems. So we're going to go ahead and take a look at this example right here. If we went to graph this, we would have to put it into y equals mx plus b, so we'd move the 2x over, divide by 4, and we'd get an equation. Then we'd have to go over here and graph it. And that requires a lot of work sometimes, and some people just aren't a big fan of graphing. The substitution method, we would have to solve one of these for one of the variables, plug in, and it works out to come out with a lot of fractions, and it's not as pretty as we like it. So this next method that we're going to take a look at today will allow us to not have to use the substitution method. The elimination method is probably one of my favorites. So let's go ahead and take a look at this. Without using the substitution method and without graphing, we're going to try to find a way to solve for our different variables here, and let's go ahead and take a look at it. So we've got 2x plus 4y equals 8, and we've got negative 2x plus 2y equals 4 as our two sets of our systems of equations. The elimination method literally just goes by its name. We're going to eliminate one of the variables. The way we eliminate one of the variables is we're going to go over here and identify to see if we can add something or subtract something or get something to essentially eliminate itself out. I picked us an easy example here, and we're going to just go ahead and jump right into it. So if we look at this, we've got 2x and a negative 2x. If we check what 2x minus 2x equals, that equals 0x, and 0 times anything equals 0. So what we're going to be able to do, and what we're really going to look for, this one works out nicely because it's just given to us, and eventually we're going to have to do some other things to it. But this one, starting off with an easy one, cancels out immediately. So right off the bat, we're able to say what we're going to do is add the top equation to the bottom equation. 2x subtracted to 2x cancels itself out like we have aforementioned above to 0x. 4y plus 2y is 6y, and 8 plus 4 equals 12. So essentially all we're doing is just adding straight down. And now we have eliminated one of the original variables, and now we are able to solve a problem that looks like so. We've got 6y equal to 12. We're going to divide by 6 and get y by itself, and y equals 2. Now, this is not our answer. We are still one step away from getting to our answer, because remember, our answers to any type of system should be a solution set where we get an x and a y. So now that we have the y, let's go back and find an x. When we get this, you're going to have to go back and plug into one of the original equations. Whichever one works out easiest for you guys, doesn't really matter. As long as you plug it into one of the original two, you'll get the same answer. So let's go ahead and look at this. I'm going to pick the first one just because. 2 times x, because we still have to solve for x, plus 4 times what y is, and y is now 2, and that equals 8. 4 times 2 is going to give us 8, equals 8. There's a positive 8, and we've got 2x. We're going to subtract 8 from both sides, and that gives us, that cancels out, and this goes out to 0. So we've got 2x equals to 0, divide by 2, and x equals 0. So now this gives us our answer, and the solution and the point of intersection of these two lines at the x value of 0 and the y value of 2. Now, it may require a little bit more work than some problems, but it definitely takes a lot of the headache out of using fractions and solving, and try to think about which one you want to solve for if you're trying to use a substitution method. Best way, in my opinion, is to learn something is just to try another example here. We're going to try a little bit more of a difficult one here, and this one's not going to work out as nicely. So let's try this next example here. Let's try that if we've got 8x minus 6y equal to negative 20, and negative 16x plus 7y equals to 30. Now, if we're looking at this one's a little bit more difficult than the last one we took a look at, because the first one we took a look at, 2x and negative 2x just canceled each other out, and we didn't have to do anything to it. But now we've got 8x minus 6y equals negative 20, and negative 16x plus 7y equal to negative 30. Now this one is basically a step up from the one we had before. The one we had before, simple, straight to the point, we can directly get there. Now if we look at this one, 18 minus 6, or 8 minus 16 is a negative 8, and negative 6 plus 7 is a positive 1. There's nothing that can be eliminated right off the bat. So if we get into a circumstance like this, what we need to do is look for the easiest variable to match up and make, like we had before, 2 and 2 match up. So if we look at this, let's start off with our y's. What are our common factors? You're going to try to find the least common multiple. The least common multiple between the coefficients in front of the variables. So the least common multiple of negative 6 and 7. So we've got our factors 6, 12, 18, 24, 30, 36, and 42. 42 is going to be the least common multiple that we have between 6 and 7, because 7 we've got 14, which is a little bit more than 12, 21, which is a little bit more than 18, 28, which is just a little bit more than 24, 35, and then we get to 42. We can multiply and get to the same number of 42 here, but there might be an easier option over here. If we look at 8 and 16, what is the least common multiple between 8 and 16? The least common multiple between 8 and 16 is 16. How do we get to 16 from 8? 8 times 2 equals 16. So if we've got 8 times 2 equal to 16, we're going to want to have to multiply everything on the top equation, the first equation that we're looking at. We're going to multiply everything by 2. So we're going to multiply the 8 by 2, the negative 6 by 2, and the negative 20 by 2. When I do these, I like to put them beneath the next equation. If we multiply 8 times 2, we've got a positive 16x. We multiply the negative 6 times 2, which gives us a negative 12y. And then a negative 20 times a 2 equals a negative 40. Now, with slightly larger numbers than the first example, we have an ability to eliminate the x variable. Just a side note here, just the two first examples I've picked just happen to eliminate x first. Sometimes it might be easier to eliminate y first. So don't get the notion that, like I think we got in class the other day, that we have to eliminate y first, because our first couple examples were y equals mx plus b, and it was easy to substitute that way. I don't want us to get into that mindset. I want us to be able to think that let's find the easiest method for us to eliminate the variable. Okay, now back to this example. Now that we've got negative 16x plus 7y equals 30 and a positive 16x minus 12y equals to negative 40, let's go ahead and just add straight down. Negative 16 plus 16 is a 0x. 7y minus 12y is a negative 5y. and 30 minus 40 equals a negative 10. So this has now been eliminated, hence the elimination method. So now all we're left with is negative 5y equal to negative 10. We're going to solve for y divided by negative 5. Negative 10 divided by negative 5 is a 2, and we've got our y value of 2. Now we have to go back to one of the original two equations. We don't want to use the one our new equation when we multiply by 2. We want to go back one of the original 2's just to stay consistent. Doesn't matter which one we pick. The first example, I picked the first equation. This example, I'll pick the second equation. Like I said, doesn't exactly matter. So we've got negative 16x, that's what we're trying to solve for here, plus 7 times y, which we now know is 2, equal to 30. We've still got negative 16x, 7 times 2 is a positive 14, equal to 30. We're going to subtract 14 from both sides. That is now gone, and we have a negative 16x equal to a 16. We're going to divide by 16 on both sides, and x equals negative 1. Now our answer, remember I want us to write our answer as an ordered pair, so our x value is negative 1, and our y value was 2. So now we're going to try to take a look at another example here where you're going to have to multiply both equations to get to a least common multiple that will work out nicely for us. Maybe we'll try another one. So there will be times where you'll have to multiply the first equation by something and the second equation by something. So let's try to take a look at an example of something like that. Let's say we've got a 4x plus a 2y equals to 16. And maybe we've got a 5x minus a 3y equals to 12. I just made this problem up in my head. Don't know if it's going to work out perfectly, so let's just see what happens. So this is our third example here. Once again, we're going to use the elimination method. But as we can see, we've got a 4x plus 2y equals 16 and a 5x minus 3y equals 12. We can't add straight down because 4 plus 5 is 9, 2 minus 3 is negative 1, and nothing eliminates itself. So now we have to start thinking of what are our least common multiples between the coefficients with x and the coefficients with y. It doesn't matter which one we choose. I'm going to go ahead and choose y here just to prove that you guys that it's okay to choose y first. So let's think of our least common multiples between 2 and negative 3. We've got 2, 4, 6, and 3, 6. There we have our least common multiple. So what we need to do is get our top equation, our y value, to be 6. To do that, we're going to have to multiply by 3. 4 times 3 is 12x. 3 times 2 is a positive 6y. And 16 times 3 is a 48. To get to our second equation, a y value equal to 6, we're going to have to multiply the bottom equation by 2. 5 times 2 is a 10x. 2 times a negative 3 is a negative 6y. And 2 times 12 gives us a 24. And now we have the same situation like we had in the original problem, where one of our variables gets eliminated. When we eliminate a variable, we're able to have a positive and a negative of the same number with the same variable. 6 minus 6 gives us a 0y. 48 plus 24 gives us a 72. And 12 plus 10 gives us a 22x plus a 0y. This has now been eliminated, which gives us a 22x equal to a 72. To solve for x, we're going to divide by 22 on both sides, and we've got an x equals a 72 22seconds. This can be simplified. If you don't know what this can be simplified right away, both of them are even, so let's just divide by 2. 72 divided by 2 is a 36, and 22 divided by 2 is 11. At this point, 11's prime, we can no longer simplify any farther. So x equals a 36 elevenths. Now we're not done yet because we still don't know what y is. We're going to go back in, pick one of the original two equations. I'll just pick the first one just because I've been alternating here. We've got a 4 times what the x value is, which is a 36 elevenths, plus a 2y equals 16. So now we're going to have to multiply 4 times 36. 36 times 4, we're going to do some old school math over here. 36 times 4, 6 times 4 is 4. Carry the 2. 4 times 3 is 12, 144. So we've got 144 over 11 plus 2y equals 16. To move this over, we're going to have to subtract 144 elevenths from both sides. And that gives us a 2y equals a 16 minus a 144 elevenths. So now we have to take care of an issue here and give us a common denominator between 11 and 1. The least common denominator of 11 and 1 is 11, so once again we're going to have to do some old school math up here. We've got 16 times 11. 16 times 1 is just 16. And then we've got 176. So now we've got a 176 elevenths minus 144 elevenths equal to 2y. 176 minus 144 gives us a 6 minus 4 is a 2. 7 minus 4 is a 3. And that gives us a 32 elevenths. So we've got 2y equal to 32 elevenths. We still have to divide by 2 here to get us our answer. When we're dividing by fractions, that's the same thing as flipping and multiplying. So we've got y, that's a y here, equal to 32 elevenths multiplied by a 1/2. We can do some cross reduction here. 32 over 2 is 16 over 11, and that gives us our y value. Obviously this problem came out not as pretty as the first two, but imagine trying to graph this. That would be extremely difficult to identify where 16 elevenths is and 36 elevenths is. And this is one of the main reasons this method I would use as much as I can. Unless we have a direct substitution that's pretty easy, when we come to the test there's going to be questions where you're asked to do specifically by graphing, specifically by substitution, or specifically by elimination. But then there's going to be questions where it's going to be a your choice, a dealer's choice. And you're going to be able to, you pick on the test. And there will be ones that are clear to use the graphing or the substitution or the elimination. But when in doubt, I always turn to our elimination method. We're still not done yet with our last problem here. We still have to write it as an ordered pair. Our x value is a 36 elevenths, and our y value is a 16 elevenths. And that would be the point of intersection for these two lines. That concludes what we're going to discuss today. Over the weekend, you will have a worksheet for homework. Any questions that we have, I know I'm not there today, and I won't be there for North Time. You can go see anybody in room 247, any Algebra 1 teacher. That is the Algebra 1 room. So if you have any questions, go see them. If not, I'll be back on Monday. I can answer any questions and we'll cover this again. So get your homework done, have a good weekend, and come ready with any questions that you have over the elimination method.